Welcome, tech enthusiasts and future-forward developers. Today, we're diving deep into a topic that's critical for every modern software project: enhancing security in Java DevOps with AI scanning. In the fast-paced world of continuous integration and continuous delivery, security often feels like an afterthought, a necessary but slow step. But what if we could integrate intelligent, proactive security measures directly into our development pipelines, making security faster, smarter, and more efficient? Join us as we explore how artificial intelligence and machine learning are revolutionizing static application security testing, allowing us to catch vulnerabilities early, consistently, and with remarkable accuracy. We'll specifically look at how tools like SonarQube, augmented with powerful AI capabilities, can transform your Java CI/CD pipeline from a potential weak link into a fortress of robust, secure code. Get ready to level up your understanding of DevOps, because the future of software security is here, and it's powered by AI. Traditional static analysis tools have been instrumental in identifying known patterns of vulnerabilities. They're like diligent librarians, checking every book against a massive catalog of known issues. However, the sheer volume of new code, complex interactions, and evolving threat landscape often overwhelm these rule-based systems. They might miss subtle, context-dependent flaws or generate a high number of false positives, which can lead to alert fatigue among developers. Imagine scanning millions of lines of Java code. Relying solely on predefined rules can be like searching for a needle in a haystack with only a magnet that works for iron. Modern applications often use complex frameworks, custom libraries, and intricate business logic, creating new attack vectors that don't fit into a simple regex or signature database. This is where AI and machine learning step in, bringing a new dimension of intelligence to the security analysis process. AI scanning in static analysis moves beyond simple pattern matching. It leverages machine learning models trained on vast datasets of both secure and vulnerable code, understanding the context and intent behind code patterns. Think of it as an expert security auditor who has reviewed millions of code bases, learning to spot not just obvious flaws, but also the subtle indicators of potential vulnerabilities, architectural weaknesses, or even logic bombs that could be exploited. Instead of just flagging a known insecure function, AI might identify a sequence of operations that, while individually benign, collectively create a critical security flaw. For Java applications, this means deeper insights into how data flows, how objects interact, and how configuration might expose sensitive information, even in highly abstracted frameworks. This predictive and contextual understanding significantly reduces false positives and uncovers deeper, more insidious threats. SonarQube is a widely adopted open-source platform designed for continuous inspection of code quality and security. It acts as a central hub where all code analysis results are aggregated, visualized, and managed. Initially, SonarQube provides robust static analysis capabilities right out of the box, supporting numerous languages including Java. It identifies bugs, code smells, and security vulnerabilities based on a comprehensive set of built-in rules. For Java developers, it meticulously checks for common issues like null pointer exceptions, unhandled exceptions, resource leaks, and basic security flaws such as SQL injection or cross-site scripting. It presents these findings on a user-friendly dashboard, giving development teams a clear overview of their code health and security posture. It's the foundation upon which we can build more intelligent security layers. While SonarQube is powerful on its own, its true potential for advanced security analysis is unlocked by integrating AI/ML-driven plugins. These plugins often come from commercial vendors specializing in application security, or can even be custom developed within large enterprises. They augment SonarQube's rule-based engine with machine learning capabilities, allowing it to perform more sophisticated threat detection. Imagine a plugin that uses deep learning to understand the semantic meaning of code, rather than just its syntax, identifying vulnerabilities that only manifest through complex interactions between different parts of an application. For instance, an AI-powered plugin might detect a potential deserialization vulnerability in a Java application by analyzing how serialized data is processed across multiple classes, even if no single line of code explicitly violates a simple rule. These plugins analyze data flow, control flow, and even predict potential future vulnerabilities based on historical patterns of exploitation, significantly enhancing the depth and accuracy of the security scan results. The Java DevOps pipeline is a sophisticated automated workflow designed to build, test, and deploy applications rapidly and reliably. It typically begins with developers committing code to a version control system like Git. From there, a CI server, such as Jenkins, GitLab CI, or GitHub Actions, automatically detects the changes. This triggers a build process, often managed by Maven or Gradle, which compiles the Java code, runs unit tests, and packages the application. Following successful builds and tests, the application proceeds to various deployment stages, potentially involving artifact repositories, staging environments, and finally, production. This entire journey is orchestrated to ensure speed and consistency, but each stage also presents an opportunity to embed security. The seamless flow from code commit to deployment is precisely where AI-powered security scanning can be most effective, acting as a vigilant gatekeeper at every critical juncture. Embedding SonarQube with its AI or ML capabilities directly into your CI/CD pipeline for Java projects is surprisingly straightforward and incredibly impactful. The most common approach involves integrating SonarQube as a dedicated build step. For Maven or Gradle projects, you simply configure a plugin that triggers the SonarQube analysis after compilation and unit tests are complete. In Jenkins, this might be a SonarQube scanner plugin step within your pipeline script. For GitLab CI or GitHub Actions, you'd add a specific job or step that executes the SonarQube analysis command. The crucial point here is that the scan happens automatically with every code push or pull request, ensuring that security checks are never skipped. This shift-left approach means vulnerabilities are identified within minutes of being introduced, rather than days or weeks later, drastically reducing the cost and effort of remediation. It becomes an integral part of the development cycle, not an external audit. Effective security in a DevOps pipeline isn't just about finding vulnerabilities, it's about enforcing policies and standards. This is where security policies, often implemented as quality gates in SonarQube, come into play. A quality gate defines a set of conditions that must be met for a new code version to pass. For example, a security policy might dictate, no new critical or major security vulnerabilities are allowed, or the security rating must be A. With AI scanning, these policies become even more powerful. An AI-enhanced policy might include conditions like, no code patterns identified by the ML model as high risk for deserialization vulnerabilities, or maintain a security hotspot density below X% as determined by contextual AI analysis. These policies act as non-negotiable checkpoints, preventing insecure code from ever reaching production. They are configurable, allowing organizations to tailor them to their specific risk appetite and compliance requirements, ensuring that security is truly baked into the process. Now, let's visualize AI in action within our Java pipeline. Imagine a developer commits a seemingly innocuous change to a Java Spring Boot application. Traditional SAST might scan for known OWASP top 10 issues. But with an AI-powered SonarQube plugin, the analysis goes much deeper. The AI model, having learned from millions of lines of code and numerous real-world exploits, might detect a subtle combination of an insecure configuration setting, a specific data deserialization pattern, and a custom exception handler that, together, create a severe remote code execution vulnerability. This isn't just a simple regex match for runtime.exec. Instead, the AI understands the flow of tainted data, the context of its processing, and predicts the likelihood of exploitation. It might even suggest a more secure alternative or flag the code as a security hotspot requiring manual review, with a high confidence score, dramatically reducing false positives and identifying zero-day-like vulnerabilities before they become public knowledge. Once AI scanning has identified potential security hotspots or critical vulnerabilities, the next crucial step is triaging and remediation. SonarQube provides a centralized dashboard where all findings are presented in a clear, actionable manner. Developers can drill down into specific issues, see the exact line of code, understand the vulnerability type, and often, get recommendations for remediation. For critical issues identified by AI, the context provided is usually richer, detailing the data flow or the semantic reason for the flagging. This integration often extends to issue tracking systems like Jira. A failed quality gate or a newly detected critical vulnerability can automatically create a Jira ticket, assigning it to the responsible developer or team. This streamlines the remediation